name is Kelly Powell. I'm with the Inveno Engineering LLC. We are a engineering firm focused totally on steam and condensate systems. Today I want to talk about our virtual steam system engineering support program that we have for our customers. And I want to go through the root cause analysis case study number 28, which we just completed. During these trying times, we came up with a program to support our clients during COVID-19. As you know, plant access can be limited or non existent. There's still a need for engineering support. That's not going to change. So we developed the following program to meet our clients' needs and requirements for engineering support. And I want to go through case study number 28. This happens to be a rotating steam dryer that one of our clients submitted to us. The dryer is not achieving a constant surface temperature, which ends up with loss of production and, of course, product rejects. Our root cause analysis investigation looks at the original design, operation, and the current operation, installation, operation, and, of course, safety compliance. One of the first things that we came and saw during our investigation is there is no functional pressure gauge here at the inlet. Therefore, we don't know exactly what the pressure, steam pressure is. As you know, the boiler operating pressure isn't what the pressure is at the end of the process because we're going through piping, control valves, isolation valves, possible flow meters. So it's really necessary to have a operating pressure gauge prior to the process. It tells us so much. The other thing is we looked at these ball valves which are not code compliant. They're not meeting the pressure and temperature rating for the maximum steam pressure for the system, which is the set pressure of the safety valve. Now, there's nothing wrong with the valve. It's just rated for a lower pressure and temperature. Upon further investigation, the steam hoses that were put in here have a reduced diameter, which is restricting the steam flow to the rotating dryer. The other thing is there's a reduction of the steam hose size going into the inlet connection. Remember one thing on heat transfer, if the inlet connection is 1.5 inches, then it should be an 1.5 inch hose or connection. If it's 1 inch, it should be a 1 inch hose. So always match the inlet and outlet connections on all heat transfer to make sure you do not have a restricted flow going to the process and removal from the process, which is condensate. The other thing is the hose is not rated for B31.1, which is the National Power Piping Code. Everything that you put in the system must be rated for the maximum pressure and temperature. The other thing is when we're coming out of the rotating dryer, we want to drop down 20 inches or more. They just assist us in getting the siphoning action occurring on a rotating dryer. The next thing we looked at was the drainage, which is always a critical part of it. The thing is that yes, there is a strainer, which is good. All steam trap stations must have a strainer. However, there was no blowdown valve on the strainer. And an investigation from the plant personnel, the strainer was probably around 30 to 40% plugged. So next we looked at the steam trap design. It's a floating thermostatic design steam trap, which is the best steam trap design for this application. However, inside the steam trap here, the orifice was not the correct orifice and was reducing the capacity of the steam trap. So we need to have the correct orifice in the steam trap. The other thing is threaded connections. During operation, there is significant leakage from threaded connections, and we want to eliminate threaded connections in steam and condensate systems or reduce them dramatically. Only use them when it's necessary. The next is there's a check valve. This application doesn't need a check valve. Just because you put a steam trap in doesn't mean you need to have a check valve after the steam trap. So if backflow can occur, then you need a check valve during operation. However, this application, there's no way backflow can occur. The other thing is, of course, we need an operational pressure gauge here to see what the back pressure in the system is. The other thing on rotating dryers, what we like to do is put a needle valve here and let a small percentage of steam flow through to the condensate return system, and that's signified as blow-through steam. It helps the siphoning action from a rotating dryer. Therefore, we come up with the short-term solution. Short-term, replace the steam hoses with correctly sized and rated for the maximum pressure and temperature. The next is put in the correct orifice in the steam trap. You do not have to replace the steam trap. Just remove the existing orifice and put a new orifice in. We have included a technical data that goes through the requirements needed for the orifice change out. Isolation valves, replace them with a isolation valve that's rated for the maximum pressure and temperature so they're code compliant. Install pressure gauges, on the steam supply in and the condensate return out. So we know the differential pressure across the system and across our rotating dryer. Install ball valves on the strainers for blowdown and have a PM for blowing down the strainer. Remove the check valve. There's no need. There's not backflow can occur during operation with this type of process. Long term, install ball valves for isolation. You always use ball valves, the latest technology. Design and standardize on a proper steam trap station, and this happens to be just example of one steam trap station. Everything is compact. We try to use as much as possible universal connecting type steam traps and lockout, tag out type valves. And the other thing on this here is we eliminated threaded connections as much as possible, but tube connectors are guaranteed not to leak, so we're not going to have any leakage in that system. The next, we added in a technical paper on steam system heat transfer components, which is part of a best practices up at our website, and our address of our website is on the screen there, www.invenoeng.com, and there's 64 best practices up there, and videos and articles on steam system. Our approach: short term, steam system balancing, steam system reliability, steam system engineering training. Long term, implementation engineering, project design, project full engineering support for steam system changes or upgrades or anything that our clients might need in regarding steam and condensate systems. Our contact information is right there. Our email addresses from our 2 senior field engineers, and our other engineering support group is there to help you out. With that, we want to say thank you, have a great day, and let us know if you need more information on our virtual engineering support. You can contact me or Graham, or contact our system people through our website, and have a great day. And here is the website again, and have a great day.